Hi there, and welcome to our project. In this video, we'll be discussing the procedures that we went through in order to design and manufacture a fixture, a part, and the results from that work. From this project, we hope to learn many things, including how to design and machine fixtures, how to use the geometry of fixtures economically, and how to hold parts onto said fixtures using Mitee Bite products. Learning how to fixture parts and what to use to fixture them will be a very helpful skill for our future. We designed a part to be held in the fixture that could be machined in 2 operations and loaded and unloaded in under a minute. Using a combination of engineering knowledge, fixtures supplied by Mitee Bite, SolidWorks, CAM, and Haas CNC machines, we plan to accept this challenge and accomplish our goals.
As the second lab project in IME 450 Manufacturing Process and Tool Engineering at Cal Poly State University in San Luis Obispo, we were presented with the task of creating a fixture for a 2-op part. The project built on fixture design fundamentals that we learned in the lecture portion of the class in a hands-on and practical manner. The skills that we have developed due to having completed this project will ultimately allow us to be well-rounded and efficient professional engineers. We were presented with a fixture base of dimensions 9 1/4 by 4 1/4 by 1 inch that needed to satisfy the following requirements. The fixture needed to mount on a Haas VF2 work table with the ability of indicating its orientation with respect to the CNC machine's axes. The fixture needed to hold the raw stock in one location and the part after the first operation in another location simultaneously. The work offset locations needed to be established for both operations using fixed datums. The unloading and reloading of the parts of the stock needed to be done in under 1 minute. The clamping force in both operations needed to withstand the tangential cutting force exerted by the mill while accounting for a safety factor of 2. After deciding on the final part to be machined, we set off on the task of designing a fixture that would satisfy all of our requirements. In order to hold the fixture to the Haas VF2 work table, we milled out 2 countersunk open slots into the fixture stock. We were then able to use step blocks and flange bolts to secure the fixture to the work plate. The raw stock to be used in the machining of the part had dimensions of 3 1/8 by 2 1/4 by 1 inch. Seeing as we essentially needed to have 2 parts on the fixture during the machining operations, it took a little bit of ingenuity to determine the position and location of the parts. The most difficult aspect during this portion of the design process was determining where the locating elements and clamps could be placed while still allowing access to them. The first operation was easy to determine where its locating and clamping mechanisms should be placed. We used 1 locating rail and 1 locating pin to place the part, and 2 cam action Mitee Bites to hold the part in place. Due to the shape of the part after the first operation, we had difficulty in deciding where to place locating and clamping mechanisms. Issues with access of the part led us to initially try to restrain the part only in one axis while still locating in both. We were regretful of this decision as soon as we started machining the second operations. After throwing a few parts, we decided to redesign our first operation to involve the drilling of a strategically placed through hole into the leftover stock material. This then allowed for the placement and access of a clamping mechanism in the y-axis. After making these slight modifications, we were successful in completing the task.
The part and fixture plate were both manufactured on the Haas VF2 CNC machine. Creating the G-code for the part and fixture was done through HSMWorks. Once the fixture plate had been machined and after the Mitee Bite's parts were mounted, an initial test mounting to the bed of the CNC machine was attempted. Using a dial indicator in the tool holder, we ensured that the indicating surface was parallel to our x-axis. Once the fixture bolts were torqued into place, we mounted the stock in our fixture to ensure the Mitee Bite clamps and locating rails were properly positioned. The first time we tried to machine our part, we found that the clamping force was not strong enough to hold the part in place, and the part was falling out of the machine. In order to account for that, we redesigned our fixture with more support on all sides of the fixture. The parts were both loaded and unloaded within a minute, completing our goal. We visually inspected the parts to make sure that the surface finish of the parts was adequate.
So after weeks of designing and fabricating our fixture to utilize Mitee Bite clamps for machining out our parts, we had finally sent our fixture and parts on their maiden voyage. We slid open the doors to analyze the aftermath of our first operation. And what we saw was the most beautiful thing we've ever seen. The Mitee Bite clamps did their job, and we had a beautiful part patiently waiting to be relocated for the second operation. Upon closer examination, we were unable to notice any defects from the first operation. So we relocate it back into our fixture, cinch it down with our Mitee Bites, and jump right into the second operation. The 3-inch flat end mill comes down and hits it with the first facing pass, but at this point, our part dislodged from the fixture and violently launches across the inside of the Haas VF2. So we gathered up our fixture, CAD files, and composure, and head back to the drawing board to figure out what went wrong and how to best troubleshoot it. We quickly realized we had poorly positioned our Mitee Bite clamps to properly grip the workpiece while inducing such heavy loads. We made changes to the fixture accordingly, added a second clamp to the fixture and a little piece of shim material to support the part, and we were ready for the second op. We set up our part in our newly designed fixture, and we're ready to run it. Operation 1 is a success. Operation 2 is a success. At least in the sense that our Mitee Bite successfully held onto the part for the entirety of the process. When we pulled out the finished part, it appeared that the G55 location for the second operation was off about 0.010 of an inch in both the X and Y directions. The only noticeable effect that this had on the part was an uneven chamfer along the hole and outside edges. We were able to adjust the G55 offsets on the CNC machine and rerun but some sections of the chamfers were noticeably larger because too much material was removed on the first run. After redesigning the fixture and properly locating the G54 and G55 offsets, I would say that this fixture was successful at doing what was required of it. It was able to produce several high-quality parts, and the Mitee Bites allowed effective holding of the workpiece and quick cycle times between operations. While this current fixture is great for what we were doing in this lab, there are plenty of ways to still improve it. I think we could cut down machining time by increasing feeds and speeds, but that would likely require heftier clamping than what we currently have set up. We could potentially do this by adding more of our current Mitee Bite style clamps, or perhaps using a different style of clamp, also obviously provided by Mitee Bite. It is also possible to redesign the fixture in ways that would minimize loading and unloading times between operations, or even possibly machine more parts at one time, which would also decrease cycle times. That is all. Peter, out.
After some hard work, the team was able to successfully design and manufacture a keychain which doubles as a bottle opener, along with the corresponding fixture to produce this part. Utilizing SolidWorks, the Haas VF2s available in the IME labs, and Mitee Bite fixture clamps and locating rails, our team was able to meet the design requirements. As stated earlier, improvements to the parts and fixtures will always be possible. The fixture could be designed in order to hold more parts at one time, or adding extra clamps or stronger clamps would allow the fixture to handle greater cutting forces. Also, considering the fact that our part is intended to be a keychain, the design should be greatly scaled down. The other feature of the part that could use some attention would be the bottle opener and through-hole section. The thickness in this area could be greatly reduced to better accommodate a keyring. One of the most important results came from the issues encountered during the project. The biggest issue was ensuring proper clamping of our parts. Our first design greatly underestimated the forces of our machining operations and resulted in the launching of parts mid-operation. These tests verified the fact that a redesign with greater support was necessary. From this failure, we were able to learn more about the force required to fixture a part, and the most important thing that we learned, that with Mitee Bite, it'll always work right.